Good evening, our students, and welcome to our discussion this moment. Today, we want to start discussing the sampling distribution of sample proportions. And then, this moment, we are looking at sampling distribution of the difference between two sample proportions when sampling is done for with replacement. In different comparative analysis or studies, interest might be to compare two different populations in terms of their means. And then when we want to compare two populations in terms of their means, it is important that one studies the distribution of sample means. But then in some other contexts, the interest could be to compare two different populations now in terms of their proportions. And that is exactly what we are going to do this moment. So we are going to consider two populations, and then we are going to tag these two populations, population 1 and population 2. So let us say we have population 1, we have population 1, and then we have population 2. Population 2. And let us say that we have information that the population proportion of this population 1 is given by P1. Let us say we have the information that the population proportion here is given by what? P1. When we say or we talk about population proportion, our interest could be on the proportion of defective items in that population 1, or the proportion of students who passed exam from the entire population of what? Of students. So it could be any characteristics of your interest that you are looking out for all over the entire items in that kind of population. That is what we mean by what? By proportion. Let us equally see that we have idea here that the population proportion here, the population proportion here, population proportion is given by P2. Okay. Then we are to come to this population 1 and we take a sample of size N1. We are going to take a sample of size N1. So I come here, I take a sample of size what? N1. And I equally go over to population 2 and I equally take a sample of size N2. So I have sample of what? Size what? N2. And let us say that the items that are contained in this my sample N1 are given by, I have 1, I have 2, I have 3, I have 4, down to my N1. And when I come over here, I equally have in this sample N2 as 1, 2, 3, 4, down to my N2. And then if we are looking out for defective item, and then we have taken a sample from this population 1, and the sample we have taken contains elements from 1 to N1. Each of the item we come to can either be defective or it cannot be defective. The same thing applies here. Each of the elements can either be defective or non-defective. Let us say that when it is not defective, then a random variable, let us say that when it is not defective, we assign 1 to it. But when it is defective, we assign 0 to it. Let us put it that way. In that case, what I'm going to have here becomes, I will define a random variable. That random variable I'm going to define, let it be what x what I. This xi here is going to assign 1 if it comes to any particular item in that sample and that item is non-defective. It will assign 1 to it and it will call it success. Success. And then it will now give it what 0 if that item is defective and it calls it what failure. Failure. The same thing applies here. A random variable will come called what x what I. It is now going to what assign what 1 for success and then assign 0 to failure. So having defined this random variable that counts for us the number of successes and then the number of what of failure. If I want now to determine then the total number of successes which I have in this particular sample N1 coming from population 1, it is as good as summing this random variable. So let me define that the total number of my successes is given from population from sample 1 is given as what? Y1. And this Y1 will be given as summation that I is running from 1 to N1 of what? X what I. Reason. This random variable will continue to assign either 1 or 0 to each of these elements. It will come here. It will assign 1 or 0 to this element. It continues till the end to this n subscript 1 item. Therefore, if it assigns 1 here and assigns 0 here, for instance, and assigns 1 here, summing all of them, when you are adding 0 to anything, it doesn't change anything. So when you are summing this xi, it's as good as you are summing the 1 there. Because when you are summing 0, 0 doesn't change the value. So that's why we are saying that the total number of successes y subscript 1 is given as sum. I is running from 1 to n1 of xi. The same thing applies here, that we are going to define what y what 2, and this y2 is going to be sum that I is running from 1 to n what 2 of what x what I. So this is total number of successes from sample 1. This is total number of successes from sample 2 coming from population what 2, and this one coming from population 1. Now, we want to determine, first of all, what is the distribution of y1 and what is the distribution of y2. When we talk about the distribution of y1 and y2, we are going to make reference to with replacement and without replacement. But what we are discussing now is for with replacement. Now, if sampling is for with replacement, it means that if I come to this population 1, and I draw the first sample, say, and say 1. I must return this 1 to this population before I draw the next sample. And I continue in that order now till I get all the elements up to my N1. And because the sampling is for with replacement, it means that each of these elements in these samples are independent of what? Of each other. And each of the elements can either be what? Be success, or it can either be what? Failure. And any random variable that can either be success or failure at any particular point in time is a Bernoulli random variable. So each of these items is a Bernoulli random variable. And we are told that when we sum Bernoulli random variables, independent Bernoulli random variables, that we are going to get a binomial random variable. And of course, you know that this my yi here is the sum of the independent Bernoulli random variable. So this my yi now therefore follows a binomial distribution. And because it follows a binomial distribution, it implies that my y1 follows a binomial distribution. The parameters are going to be what? n1 comma what p1. This is the parameters of that y1. The same thing applies with y2. It is going to be that my y2 now is going to follow what? Binomial distribution with parameters what? n2 comma what? p what 2. These are the parameters of this binomial distribution. One thing we are going to look at here is if y1 follows binomial distribution with parameters n1 and n2, what is the mean? What is the variance of y1? The mean of y1 will be given as mean of a random variable is e of what y1 will now be given as what n1 p1. That is the mean of a binomial distribution. And we have shown that this y1 follows a binomial distribution, being the sum of the independent Bernoulli random variables. And then the variance var of what y1 will be given as what n1 p1 and then q1. The same thing applies here. The expected value e of what y what 2 will be given as what n what 2 p what 2. And then the variance, which is var of what y what 2 will be given as what n1 p1 and n2 p2 and q2. So our interest here now becomes, now that we have known the distribution of y1, we have known the distribution of y2. That is not what we are looking for. We are looking at the distribution of the difference between two sample proportions. So we must first of all define the proportion. By defining the proportion, of course, proportion here is defined as we have the p estimate of 1. Here, this one is called a population proportion. This one is called a sample proportion. That is why you are seeing the estimate here. So this is given as we have summation of I running from 1 to what to n1 of xi all over what n1, which is given as what y1 all over what n1, because we have defined earlier that y1 is given as this. The same thing applies here, that my what my p cap was 2 is given as summation I is running from 1 to n2 of what x what I all over what n2, which is the same thing as that p what 2 estimate is given as y what 2 all over what n what 2. The interest is, how do we determine the distribution of a p1 estimate and p2 estimate? So at the end, we can use it now to determine the distribution of the difference. So you permit me to clean this center, so we can use this center to show how we can get the distribution of the P1 and the P2. Okay, when we want to talk about the distribution of a P1 and P2, we are going to look at it now in terms of their means and their variance. Their means and their what? Variance. So I will start from the first one. When you talk about the mean, you talk about expected value. So I will now say that expected value E of what? P1 cap is given as E of, what is the value of that? That is y1 all over what? n1. We close it. So this is equals, using this expected value to come inside this bracket, we have E of y what 1 all over what n1. This is equals to. Now, we have been told earlier that expected value of y1 is given as n1 p1. So this thing becomes what? n1 p1 all over what? n1. This n1 will cancel this n1 and we have what we call p1. So the expected value of the sample proportion gives us the population proportion P1. Then we look at the variance. When we talk about variance, we now say var of what P1 cap is given as. Here it becomes what? var of this y1 all over what? n1. We close the brackets. When this variance comes inside, what you are going to have is var of y1 all over what? n1 all squared. Knowing fully well that whenever a constant comes out of what? Of the variance sign, it is going to be squared. So this will be given as. We have been told earlier that the variance of y1 is given as n1 p1. So we have here to be what? n1 p1 q1 all over. Here becomes n1 all squared. This n1 will cancel this power here, and we are left with p1 into 1 minus what? p1 all over what? n1. Reason. This my p1 here, this q1 is the same thing as 1 minus p1. So the distribution of this p1 estimate, it has a mean p1 and then variance p1 into 1 minus p1 all over n1. So we go and do the same thing with p2. If you do the same thing with p2, you are going to arrive at the values like this. You arrive at the values like this. You are going to arrive at the value that your E of what? Of a P2 cap will be given as what? E of what? Y2 all over what? N2, which is going to be given as E of Y2 all over N2, which will be given as, look at the mean here, N2P2. So we have N2P2 all over N what? 2. This will cancel this, and this will give us what? P2. So by implication, expected value of the sample estimate from population 2 gives us the population proportion of population 2. The same thing applies in the variance when we talk about var of what? Of P cap what? 2. Following the same way we did here, we are going to arrive at it as what? P what? 2 into 1 minus what? P2 all over what? N what? 2. So the concern now is, what is now the distribution of this? We now write the distribution this way. So we now write the distribution this way. So we say, therefore, our P1 cap follows a distribution. And this distribution has parameters P1, comma, P1 into 1 minus P1 all over N1. Then when we come to that of P2, we now see that P1, P2 cap follows a distribution with parameters what? P2, comma, P2 into 1 minus P what? 2 all over N what? 2. We close the what? The brackets. So we are now going to determine the distribution of the difference between P1 cap and P2 cap, making use of these particular distributions of P1 and P2. So when we talk about what? The difference, we have P1 cap minus P2 cap. We want to determine the distribution of this. And it is going to be given as, we are going to first of all get its mean and get its variance for us to put it in form of distribution like this. This is going to be given as E of P cap 1 minus P cap what? 2, which now becomes what? Using expected value to come inside, E of P1 cap minus what? E of P2 cap. This will be given as E of P1 cap is P1 here, so this is P1 minus E of P2 cap is given as this, so this is what? P2. Which means that the mean of the difference between two sample proportions is simply the difference between the two population proportions. So when you are asked to find the mean, expected value, average of the sampling distribution of of two sample proportions, it is the same thing as the difference between the two population proportions. When we talk about the variance will be given as this var of what? We have what? P cap 1 minus what? P cap what? 2. This will be given as, we have it to be var of what? P cap what? 1 plus var of P cap what? 2. This is how to express this kind of variance. Here we had E, expected value. Here was negative. Here still retained is negative. But here is negative. Here is positive. When you are talking about what? Variance. This thing now is very simple for us now to evaluate, because this will be given as var of P1 is already established here. var of P1 is given as this. So I have P1 into 1 minus P1 all over what? N1 plus P2 into 1 minus P what? 2 all over what? N what? 2. So this thing becomes the variance of the sampling distribution of the difference between two sample means. And then we now talk about what we call standard error of the proportion. Standard error of the difference of the proportions. Standard error. Standard error of the proportions. When we talk about the standard error, what we are just saying in NS is the square root of what? Of the variance. So, and then while we are going to write it now, we already have shown that this is the variance. So we just say that this will be given as square root of this are P what? 1 into 1 minus P1 all over what? N1 plus what? P what? 2 into what? 1 minus what? P what? 2 all over what? N what? 2. You just put it this way. Okay? Now, we want to make something clear here. If you watch this formula we have shown here and watch this formula we have shown here, we are making use of the population proportions P1, 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 P2. What if in a case where P1 and P2 are not known? If they are not known, the traditional practice is always to replace them with the sample proportions P estimate 1 and then P estimate 2 before you now begin to do your evaluations. Okay? We are going to take questions on this thing, but that is going to form another class, or let us just show one question here. So permit me to clean here. So you really know what we said in all of these things. This question says, and I write quickly, the question says that we have two factories, and these factories is factory 1 and factory 2. So under factory 1, they took a sample N1 is given as 400. And out of this 400, they noticed that the defective item in it is given as y1 is equals 280. 280. So they quickly went to factory 2. So here is factory 2. Factory 2. They took a sample of N2 and that N2 is given as 500. And then here they have Y2 which is given as 320. They have 320. That's 320. What are we now going to do? They ask us question. The question they ask us to do is we should obtain I, the mean. Should obtain the mean of the sampling distribution of the difference between the two sample proportions. So we should obtain the mean, obtain the variance, and then obtain the standard error of the proportion, STD.E. Permit me to write it that way, standard error of the sample proportions. So we now start by, this is solution. If you look at this question, you find out that we are not given the population proportions because they say factory 1, they only gave us the sample taken from factory 1 or population 1 and then the number of defective items there. So it is left for us now to determine the sample proportions. So the sample proportion, like we said earlier, is given as our P cap 1 is given as y1 all over n1. This is equals. Our y1 is 280. So this becomes 280 all over what? 400. We now say that our P cap what 2 will now be given as, here is y what 2 all over n what 2, which becomes, here is our 320 all over 500. So we have obtained our sample proportions. The next thing is now for us to get what the mean. And you know that the mean is always given this way. The expected value of P cap 1 minus P cap what 2 is given as P what 1 minus P what 2. We have shown this earlier. And we equally said that when the population proportions are not given, we are going to replace them with the sample proportions. So this will now imply that this my P1 will be replaced with this sample proportion, which is 280 over 400. So I have 280 all over 400 minus. Here, I'm going to replace it with this, so it becomes what? 320 all over 500. Okay? So whatever thing you evaluate this to be becomes the mean for the difference between the two sample proportions. When you talk about the variance, so this becomes the variance. We have already shown that the variance is given as, we have that the variance is P1 into 1 minus P1 all over N1 plus P what 2 into 1 minus P what 2 all over what? N what 2. And we said whenever we don't know this and this, that we replace it with sample proportion. So this thing becomes P1 cap into 1 minus P1 what cap all over what? N1 plus P2 all cap into 1 minus P2 cap all over what? N what 2. And we already know our P1 cap to be 280 over 400. We already know P2 cap to be 320 over 500. So we put it here, and then put it here and put it here. Our N1 is what? 400. Our N2 is 500. We can easily evaluate this. And when we talk about the standard error, the standard error, it is always the square root of the variance, which is the square root of the whole of these things here. So it's going to be square root of, we have what? P1 cap into 1 minus P1 cap plus P2 cap into 1 minus P what? 2 cap all over what? N1 all over what? N what? 2, which is something you have evaluated here. So the only thing you need to do is to take the square root of that particular thing. So summarily, what we want you to understand now here is, I'll clean this board and give you a quick recap of what we have seen thus far. So you permit me to clean the questions we have solved. So the recap there is that this our P cap 1, which is the sample proportion of population 1. The sample proportion coming from what? Population what? 1, follows a distribution. It follows a distribution with parameters P1 and then P1 into 1 minus P1 all over N1. This is the distribution. And then our P2 cap, which is the sample proportion coming from population 2, follows a distribution with parameters P word 2 into P word 2 into 1 minus P word 2 all over what? N word 2, this way. So when we now talk about the difference between this P1 cap and P2 cap, we have it that the expected value of P1 word cap 1 minus P word 2 cap is given as, we already have shown this before, it's just for us to show that our P1 cap minus P2 cap follows a distribution with parameters P1 minus P word 2 into what? P1 into 1 minus P1 all over N1 plus P word 2 into 1 minus P word 2 all over what? N word 2, this way. So this is what we call the sampling distribution of the sample proportion coming from population 1, this coming from population 2. This becomes the distribution for that of the difference between the two sample proportions. Thank you very much for your audience. Situation whereby you have questions, please do not forget to raise it in the comment section, and then we'll definitely get across to you. Stay connected while we continue to unfold classes on sampling distribution of sample proportions.